Okay, so in section 3, there's a lot going on in this section that's all related, and it all deals with taking derivative. And we're going to look at taking the first derivative and second derivative, and they tell us different things. So when you take the first derivative, we're looking for where that first derivative changes signs from positive to negative at some point. So when you change signs from positive to negative, that's going to be important, because if you're changing signs from positive to negative, you're going to have a maximum value. The other thing that we're looking for is where the signs, the positive negative goes the other way. It goes from negative to positive. And where that happens, we've got a minimum. Some things to note: that if the sign does not change, then we don't have a maximum or a minimum. And then we can look at the endpoints and determine from the endpoints if the endpoints are maximums or minimums too, based on what our derivative is. The second thing that we're going to look at is what's called concavity, and it's the way that a graph bends. And so if we're concave up, then the second derivative will be greater than 0. And if we're concave down, the second derivative will be less than 0. And then the last bit for this is the point of inflection. And this is a point on the graph where a function has a tangent line and where the concavity changes. So the biggest part on this guy, the one that we'll be most interested in, is this part right here, where the concavity changes from concave up to concave down. That's the biggest one for us, but you can also use it to determine some tangent line information as well. Okay, so the best way to work with this is to just go ahead and start working out some problems using this information. So some examples for using the first derivative test: find some local extremes and identify any absolute extrema. Well, the first thing that we have to do on both of these is we've got to take a derivative. So f prime of x is equal to 3x squared minus 12. And over here, g prime of x is equal to, and then look on this guy, we've got u and we've got v, so we've got to use the product rule. And this is going to be the derivative of the first, which would be 2x times the second, plus the derivative of the second times the first. And guess what? That doesn't change our problem at all. And what I would do is I would go ahead and factor on this guy for what we want to do. I would factor the e to the x out. So e to the x times 2x plus x squared minus 3. Well, we don't want to leave it this way. Go ahead and clean it up just a little bit. X squared plus 2x minus 3. Okay, so there's your first derivatives. And what we're going to do is we're going to make a little sign chart. Factor this guy out, the f prime out, factor it, set it equal to 0, because we want to know where our derivative goes from negative to positive or positive to negative. So set this guy equal to 0, and when we do that, there's a couple things that we can do. We can use the quadratic formula, we can factor, we can do a lot of things. I see factoring here. I'm going to take a 3 out and have x squared minus 4 equals 0. And I can divide both sides by 3, and the 3 will go away. So that gives me x plus 2 times x minus 2. And so when x is plus or minus 2, I have zeros on my graph. So what does that mean? Well, set up a sign chart, and we'll use 2, negative 2, and 2 for my sign chart, and use the two things that we're multiplying together to get 0. So use x plus 2 here and x minus 2 here. And this is really kind of a cool thing. What we're going to do is we're just going to pick a number from each of these sections of our number line, basically. And we don't care what the number is, we just care about the sign, whether it's positive or negative. So when I take negative 3 and plug it in for x, I'm going to get a negative number. When I take 0 and plug it in for x, I'm going to get a positive number. And when I take 3 and plug it in for x, I get a positive number. Do that again as well on the bottom one. So I'm going to take this negative 3 and put it in for this x right here. That gets me a negative. Put a 0 in there, that'll give me a negative. Put a 3 in, and that'll give me a positive. And what we want to do is think of, we want to multiply a negative and a negative together. And when you multiply a negative with a negative, you end up with a positive number. And when you multiply a positive and a negative, you end up with a negative number. And if you multiply a positive with a positive, you end up with a positive number. So we can look at this guy now and we can say, look, our derivative is less than 0 here. Okay, it's less than 0 from here, from negative 2. So f prime is less than 0 from negative 2 to 2. And then we can say that f prime is greater than 0 from negative infinity to 2. And f prime is greater than 0 from 2 to infinity. Okay? And that's what we're interested in. That's what we want to know. Well, go back to your previous page. When signs go from positive to negative, we have a local max. When signs go from positive to negative, we have a local max. Well, look at our problem here. We're going to go from positive to negative. We have a local max. Our graph is doing something like this. We're going, let's see here. We're doing something like this. Okay? Because remember, at 0, you have a horizontal, or at negative 2, when our slope is equal to 0, that occurs at negative 2, and you have a horizontal tangent line. So that would indicate that we have a maximum or minimum. Well, if my derivative is increasing and then decreasing, I have a maximum. On the other side, when I go from negative to positive, then my slope is decreasing, and now my slope is increasing. And so here's the flip side of that. And so somehow we would connect these two graphs together to get back to our original function. And if you were to graph x cubed minus 12x minus 5, you would see that from negative infinity to 2, the graph is increasing. And then from negative 2 to 2, the graph is decreasing. And then from 2 to infinity, the graph is increasing again. So our graph for this guy is going to look something like this. And when you put it on your calculator, you can see that. Well, we can determine a lot of that information from our first derivatives. Look at the second guy over here, and let's try and factor him out. E to the x, we want to set this equal to 0. E to the x times x squared plus 2x minus 3. So that would be e to the x. And then this guy would factor to x plus 3, x minus 1. And so on this you're going to have x equals negative 3 and 1. And e to the x, if you set e to the x equal to 0, that doesn't happen. So e to the x here, this guy, he will never equal 0. It doesn't happen. So the number line that we're going to check is only going to have negative 3 and 1 on it. But we are going to check all three pieces. We're going to check e to the x, we're going to check x plus 3, and we're going to check x minus 1. And again, all we need to know is the sign. Is it positive or is it negative? So when we check e to the x is always positive. There are never any negative values with e to the x. Okay. When we check x plus 3, we're going to be negative when we're less than 3. We're going to be positive when we're greater than 3. And when we check x minus 1, we're going to be negative when we're less than negative 3. We're going to be negative when we're less than 1, and we're going to be positive when we're greater than 1. And so my overall sign chart then is going to give me a positive here, a negative here, and a positive here. Positive times a negative times a negative. Doesn't matter what the numbers are, but we'll give you a positive answer. And so on this graph, we're increasing, again we're increasing, and then decreasing, and then decreasing, and then increasing. So this is what your original function graph will have, these type of shapes. And so where is the derivative less than 0? From negative 3 to 1. And where's the derivative greater than 0? Oops, from negative infinity to negative 3. And then the derivative is also greater than 0 from 1 to infinity. Okay, so again, here's your rules for first and second derivative tests. Okay, so here's your first derivative test. Concavity is your second derivative test. And we're going to look at a problem now with concavity. And so we need to take the second derivative of our function. And again, once we take our second derivative, we want to look where the derivative is greater than 0 and where the derivative is less than 0. And where you're greater than 0, you're concave up. And where you're less than 0, you're concave down. And so let's just dive into a problem here. Alright, so let's look at x squared on the interval from 3 to 10. So y prime becomes 2x and y double prime becomes 2. So then we want to find all the places on this graph from 3 to 10 where the second derivative is greater than 0. Well, we have a constant, and this constant will always be greater than 0. So this graph from negative infinity to positive infinity will be concave up. Okay, what does that mean? Well, think about x squared. If we graph x squared, it's going to look something like this. And the concave up just simply means that the shape bends so that the ends point, so that the left end and right end point up. And this would be a concave up type of bend. Concave down type of look, if we were going to be concave down, would look like this. And you could have several different concavities in one problem. So, for example, right here, this is concave down, and then it changes to up, and where it changes is the point of concavity, and then it changes again back to down, and then it changes again back to up. So you could have several of these going on one function. Okay. All right. So this first guy, x squared, concave up. Take the derivative of the second guy, and then derivative again. So y prime is equal to cosine x. So y double prime is equal to negative sine x. And now we're just looking from 0 to 2 pi. And we want to find what's going on, you know, here. Where is negative sine of x? Is it greater than 0 or less than 0 from 0 to 2 pi? Well, think about your graph of the sine of 2 pi. The graph of the sine, negative sine. So if I graph my normal sine from 0 to 2 pi, it would look like this. And the negative reflects it over the x-axis. So it's actually going to look like my blue line here. So what we need to do is figure out where this guy is negative. And the important points for the sine are 0, pi, and 2 pi. Those are going to be our zeros. And if you can't remember that, look at your trig chart, and you'll see that that's where the sine of x is equal to 0. So the sine is going to be from 0 to pi. From 0 to pi, the second derivative, is going to be greater than 0, so we'll be concave up. And then from pi to 2 pi, the second derivative is less than 0, so we're going to be concave down. So here we would be down, and here we would be up. And you can make a sign chart with this too. Your sign chart, the critical points that you would need to check would be, let's see, we're starting at 0, so you would need 0, you would need pi, and you would need 2 pi. And when you check a point from each one of those, and you check it with negative sine x, then what you're going to find is you'll get a negative sign here, and then at pi you'd get a positive sign here. So we know on this guy it's going to have a shape that's concave down, and on this part it's going to have a shape that's concave up. And so that's how you deal with concavity.